Salamat po sa very kind introduction. And yes, Dr. Tapang already revealed our small secret. We have been granted a small project by ECWRG, but I think we are very excited with the results because although we have not started yet, because we are going to attempt to establish an equation that does not exist in the Philippines yet. And I'm speaking about how fast would the ground move when an earthquake occurs in Philippine setting. Currently, we use equations established by foreign scientists, like those in Japan, in the US, in Taiwan, in New Zealand, but we don't have an existing equation for the Philippines, so that's a challenge. And so there's a link actually between the last speaker and myself. But I'll bring you to another world, a world of earthquakes this time, and in particular, the earthquake in Cotabato very recently. It's a very peculiar series of events. Even for us scientists, we are puzzled, still are puzzled and baffled because of the several things I'm going to mention. Now, the title of the session is about innovations. There's not much of an innovation in this presentation as far as technology is concerned, but I would say the innovation that is necessary in earthquake studies, I guess, is about the approaches that we take. Because earthquakes are so difficult to understand, we don't understand anything about them, and we'll have, therefore, to innovate our approaches. Okay, my title is, I changed a bit from what is written in the program, although the substance or the contents are practically the same. Okay, let me bring you back to about 7 years ago. We normally hear from the Seismological Institute that they record about 20 earthquakes per day. Most of these, however, are of low magnitudes, like magnitude 4, magnitude 3, magnitude 2. However, every 5 years, these statistics indicate that we experience one damaging earthquake, meaning on the average, one damaging earthquake every 5 years. But in the last 7 years in the Philippines, we've had at least 7 damaging earthquakes. And I'm showing photographs of several of them. There was a magnitude 6.7 earthquake in Negros on February 6, 2012. You can take a look at the photographs of damage over there. A year later, October 2013, an even stronger earthquake, magnitude 7.2, which flattened most of the heritage churches of Bohol. And then, next slide, please. In 2017, there were 3 actually earthquakes, but I'm only showing 2 of them here for now. There was an earthquake in Surigao, 6.7, and you are looking at photographs of infrastructure damage also. And a little weaker earthquakes, but series of earthquakes in Batangas in April of 2017. There were 4 of them in a span of less than 2 weeks. And it destroyed the Cathedral of Taal, the facade, and in the interior, in the altar of the cathedral. Next slide, please. Also in the same year, in Leyte, 6.5 earthquake. As you can see in the photographs, damaged a region, mainly the municipality of Cananga, nearby the geothermal field of EDC, and in fact within EDC. And then, I think everybody remembers this, at least those who are from Manila and nearby, like Central Luzon. The not so strong Zambales earthquake, but it caused the total collapse of a certain supermarket named Quezon Supermarket, and some other damage in the old churches also in Porac and surrounding areas. That was only this year. Next slide. So we are not expecting, statistically, we should not be expecting any strong earthquake this year because it already happened in April. But lo and behold, there were 2 more. Batanes first in July, and then finally, only about a few weeks ago, in Cotabato. Let me focus on the Cotabato earthquakes. Next slide, please. Often, scientists are maligned for being um, poor communicators as far as the science is concerned. So what we do is whenever there's an opportunity to communicate with the general public, we do accept the opportunity. And a few weeks ago, I wrote a laymanized version of what I thought or what I think the reason that there was a series of earthquakes in Cotabato in a broad daily sheet. And in that article, of course, it's highly popularized, laymanized. I wrote as simple as possible as I could. But what I'm going to do today is to try to expound a little bit on the science of what I wrote in that simplified article. So I'll start by showing this. Next slide, please. A list of peculiar things about that earthquake. One, there were 4 magnitude 6 or greater events in 2 weeks, which for now we think defies earthquake theory. Number 2, we don't have an explanation yet on how these 4 earthquakes were generated as far as existing theories are concerned. So I'll just present some options or some possibilities. Third, I'll show the initial analysis that I and my researchers in my laboratory have been doing and are still doing. And finally, the 4th bullet is about an innovative way of collaborating with someone outside of the Philippines and helping us out in trying to chase or track down that elusive fault that caused those earthquakes. So you're looking at a time-lapse animation of 2 weeks of 4 main strong events and their aftershocks, the smaller dots. So the legend shows dots in colors as well as, or circles in colors, shaded circles in colors. And the colors correspond to depth and the sizes correspond to magnitude. The bigger the circle, the greater the magnitude. So as the animation proceeds, you notice that there are 4 events between October 16 and October 31. The October 16 event occurred on the southernmost of the series latitudinally, and the magnitude was 6.3. And then on October 29, there were 2, a magnitude 6.1, and then followed by about an hour and a half later, a 6.6 earthquake. So everybody thought that it was over. But then again, 2 days later, October 31, there was a 6.5 earthquake, almost in the same area. But as you notice, they're oriented almost, or the first started in the south and then progressed northwards towards Mount Apo. The other thing you notice there is that the aftershocks of the 3 main, the strong ones, were clustered right about the town of Makilala and towards North Cotabato province. But the 4th event, the aftershocks, if you notice, the aftershocks of the 4th event, what do you notice? They proceeded towards Mount Apo. Mount Apo is classified as inactive volcano, but everybody knows that it's the tallest mountain in the Philippines and it's a volcanic edifice. Its classification, however, is it is an inactive volcano. So, when we went out to the field, of course, this was a very big humanitarian effort by the UP community to the earthquake-stricken area in Cotabato. One thing that we noticed was that the zone of damage, meaning the collapsed buildings, distribution of landslides, were concentrated along a zone that can be defined orientation-wise in a northeast direction and rather narrow, only a few kilometers wide. And while we were observing the degree of damage, we were also conscious about how they were distributed in space, meaning from above. So what we did was to take a look at satellite imagery, but before that, we were also in contact with our currently employed as instructors at NICS, but doing Ph.D. studies abroad, and requested for some information on what available satellite images would be available for us before we go out to the field. But before I go to that, when the earthquakes in Cotabato occurred in 2 weeks, the four earthquakes, I took a look at some data in the past and tried to compare what happened in the Visayas in the last 5 years. And I noticed that there were four big ones in the Visayas, but this was in a bigger region for a longer time. So we took a look at what happened in those four events, and we came out actually with some publications with some of my former advisees and now also current advisees. The earthquake of Negros in 2012 produced a damage zone of about 30 kilometers long or 40 kilometers long. But the effect of that fault zone rupturing is must have been felt or has been felt in a much wider zone than the 30-kilometer zone. And those maps you are looking at, the map actually, and the sections on the right side, indicate where the stresses have moved from the rupturing fault and away from it. And what is indicated there is that apparently, after the magnitude 6.7 earthquake of Negros, some of the stresses moved to the southeast towards Bohol. However, as can be shown in that diagram, the Bohol earthquake is shown by another, we call it a beach ball, but you know where Bohol is, it's to the east of Cebu after Negros. And it doesn't appear to have caused the earthquake in Bohol, meaning that perhaps the magnitude was too small, meaning the 6.7 earthquake, 6.7 magnitude was too small for it to trigger the earthquake in Bohol. But in Leyte, the third earthquake in the last 5 years before Cotabato, there were two earthquakes in a span of 4 days. One occurred north of the second one with a lower magnitude, 5.9, but the main earthquake was 6.5. And when we looked at the behavior of that fault as it ruptured on the first event, we noted that the transfer of stress moved to the southeast, and that's where the second earthquake of magnitude 5.9 occurred. And so we thought that perhaps the first earthquake triggered the second earthquake. So there's a phenomenon some seismologists think is a way of explaining successive earthquakes. It's called triggered earthquakes or triggered aftershocks. And so we tried to look at the four events of Cotabato and employed the same methodology, which is called column stress transfer. The main idea is that when a fault moves, the part of that fault which ruptures, which cracks, actually releases the energy that has been accumulated for many, many years, or even thousands of years. But that those stresses do not disappear in air, but simply they transfer to other places. And if there's still space in that fault, they would transfer to that segment of the fault that has not moved yet. What does that mean? It means that in those segments, new stresses will be accumulating, and therefore these areas are the likely areas where the next rupture may happen. And translated that to earthquakes, those may be the next areas where the next earthquakes may happen. So we tried to look at the four successive earthquakes of Cotabato by employing this principle. Next slide, please. So we first take a look at the October 16 and the October 29 earthquakes. And you're looking at the diagram the map to the left is a map of the column stress transfer. Don't worry too much about the numbers, but just worry about the colors. When it's blue, it means that those areas released stresses after the rupture, but the red areas are the areas where stresses have accumulated after the rupture. So you notice that the area where stresses have accumulated would be towards the northeast and toward the southwest, northeast towards Mount Apo. And indeed, the October 29 earthquake occurred towards the northeast, as if you remember the animation. So this could possibly, the 16th and the first of the 29th earthquakes could possibly have been due to triggering, meaning the October 16 earthquake triggered the first October 29 earthquake. However, next slide, please. If we take a look at the two earthquakes within the 29th, meaning the 6.6 and the 6.5, sorry, between the 29th and the 31st, they don't seem to have, the 29th earthquake, October 29th earthquake doesn't seem to have triggered the October 31st earthquake because of the observation that they happened in the same plane where the 29th earthquake already released stress. Meaning, it is not logical to think that that same rupturing fault would have generated this next earthquake. So this is what baffles us now. Could you go back still, please, to the previous slide? So it doesn't seem to have triggered that earthquake. We don't know what could have triggered, but another idea is what some call doublets, meaning one fault moving several times, therefore producing several earthquakes. Third, the next slide, please. The other thing that we noticed already, pointed this out a while ago, that the aftershocks of the October 31st earthquake, 6.5, tended to locate themselves towards Mount Apo. And indeed, if you take a look at that map, the aftershocks went towards Mount Apo. And the figures to your right are cross sections. They are slices into the earth. And the lower section, for example, there's a small triangle towards the right half of the figure. That's approximately the location of Mount Apo. And what color do you see underneath Mount Apo? Is it blue or red? It's red or orange or towards yellow. But it means an increase in stress. In volcanology, Dr. Marlagma is a specialist here. What happens when the magma chamber underneath a volcanic edifice is subjected to higher pressure or stresses? You ask him what happens. So he will make the statement. Okay. Next slide, please. So the other thing that we tried to do, as I said a while ago, is to try to seek some help from our friends outside. Because as we were looking at the trend, we could not find, for seismologists or geologists interested in earthquake studies, the most convincing evidence for a fault to have moved is when that fault ruptures the surface of the ground. When we see clearly that there is a crack on the ground and it moved. In the case of the Cotabato earthquakes, our colleagues have been there, meaning the colleagues of the Seismological Institute, have been there since October 16, and they could not find anything. But on our second day, in our fieldwork, we thought we might have found something. But before we found that something, we were helped by satellite images sent to us by an instructor at NICS but pursuing Ph.D. in Oxford by the name of Jandel Dianala. And here, there's no time to explain what it means. You just ask also Dr. Lagmay what it means. It's an interferometry, but it simply shows images, interferences, when there are displacements on the interferences, you can approximately draw a line, and that line would correspond to a possible rupture on the ground. So these images guided us in the field. Next slide, please. In looking for that elusive fault fracture. And you can easily plot it on a KML file and then plot it on a Google map as shown there. Next slide. And indeed in the field, we found something like this. What are these? These are simply cracks. Nothing interesting at all. But to an earthquake geologist, they might be telling something. And next slide. We are looking at a zone where landslides have also aligned themselves, meaning the distribution of the landslides, almost in the same line that was delineated by J.D. as he looked at his interferometry images in Oxford. Next slide. So what I'm excited to know is that if these cracks that we found in Biangan, that's a northern barangay of Makilala being the town which was most devastated in terms of infrastructure damage. We might be looking at something like this. The figure to the left is the rupture of an earthquake in February of 2003 in Masbate along a segment of the Philippine Fault, but at a smaller magnitude, 6.2. So it's not impossible that the series of 6.6 was the highest, would have also produced a rupture on the ground. We just could not perhaps find it now. So we are going back next week in Cotabato, thank you to UPRI will be providing the funds, and also all the donors, including our teammates in Mindanao. We are going back to the field and we'll be bringing some instruments to see if indeed this is the zone we are looking for. Next slide. So what are we interested in if we find that? The next thing we'll do is we'll cut a trench, dig a trench, and try to understand how many times that fault has moved in the past. And what's the interest of knowing how many times the fault is moved in the past? It's determining what we call the recurrence interval, meaning the interval in between two major events, so that for purposes of earthquake prediction, we might know when the next one will hit again. Next slide. And that's what has been done in the West Valley Fault. And that's the reason why everybody's waiting for the big one. Because the 375 years has lapsed. It should have happened yesterday. Yes. Next slide, please. I'd like to end with this. Video. It's rather anecdotal. When we were in Makilala, you see Director Jean Quaresma right at the middle of the video. We were asked to help the DRM people explain to the communities that they were supposed to be evacuating, so forced evacuation. And they needed somebody to explain bakit. And of course, scientists yung tinuro. But as I also mentioned a while ago, in general, we are very poor communicators, especially in the general public. And in fact, in this experience, that village, may dalawa silang head. There's religious head and there's a political head. Meron pa pala isa, okay. Tapos meron pang indigenous head. So we had to convince the three heads para sila na yung magpaliwanag sa local, sa kanilang tauhan. So, science syempre ang ginamit, and we were explaining actually that there was an impending landslide. And then that landslide could be again triggered by either another earthquake or rainfall. So when I was explaining, dahil ang pinapaliwanag ko yung lindol, one of the leaders, I will not mention who, among the three, sabi sa akin, sino naman kayo para sabihin na naintindihan nyo na yung lindol? Si Allah lang nakakaalam ng lindol. So you see the challenge. The challenge for scientists, it's really a challenge. Sabi ko, oo nga no. I turned back actually. Did not pursue anymore the explanation. I turned back. But that's a challenge for scientists. And I think we have to make some innovations on how we approach these things, especially in situations like this. Maraming salamat po.